All right.
Recording.
I want to ask y'all because of what happened Tuesday. Did y'all not see the announcements? Because I was always under the impression that if I put an announcement out there, it goes to your Canvas, whatever your email is, to Canvas, who Delgado, usually by default goes to those. Okay, I just want to make sure. It's just so people not checking. All right, thanks. Because I just almost, because I was at that conference and I actually logged in on my laptop just to see if there's anybody there to tell them to leave, and they couldn't hear me. I don't know what was. Anyway.
Thank you for that, Professor Cruz.
For what? Oh, fixing that? Yeah, that's no problem. I meant for it to be like that. I thought I had them all fixed.
Thank you so much. They was working in an area yesterday. So the internet went out in the midst of taking the practice. I'm like, oh no.
Well, you still got a couple of days here, but yeah, I just I must have missed that one.
Because take the test by the end of the day today, correct? Or you get back?
I don't know. We'll look at the date. What has it got on
It's day. I didn't know if you was gonna push it back just a little more time or what.
We can extend it if you want to. This is the thing is Monday, I would like to be, I want everything submitted by Monday, because Monday, what I'm gonna do is I gotta go in there and reconcile so that the grade book in Canvas is accurate, because I think it's Wednesday is the drop date. Or is it Tuesday? In here somewhere is the drop date. So I gotta have everything in, you know, just so people know where they stand.
Well, that'll be good. If you could give us a little more time.
Yeah, I don't mind doing that. We're not having a review today, and I mean, I like to at least give it a day, and if you want it on the weekend, that's fine. I just want to be able to Monday go into the thing, and I gotta have everybody, because otherwise it will submit a 0 if you didn't take it. And I
Yes, sir.
I'm already.
If you by Monday and Sunday, 11:59, you want to do it, that'd be great. Because I have a lot going on right now.
So Sunday, 11:59 is good, or did you say Monday? Because Monday, like I said, I would
No,
like.
Sunday, 11:59.
Yeah, 'cause I want to be able to go in there Monday and not have to worry about, you know, somebody's not taking it.
Thank you, Professor Cruz.
So I gotta have them all in. There's not gonna be any extension on that one. Usually I like to put a grace period in there. All right, so let's, does anybody have any questions, or do you want me to just go through the practice? Because like I said, as I know before, that people had questions about things with homework and such, if there's anything. But I mean, this is, y'all figured out my secret. I mean, the practice test is basically the test. There's some changes.
Did you start the recording?
Not yet. I didn't want to get all that talking on there, but I'll start it now. Oh, wait a minute, it's on. Okay. All right, so let's talk about some transformations here. All right. So let's just look at the basic square function. And I like to use this Desmos as it's a really neat little thing. I don't think y'all can use it on your test, but because you can. But that's the basic square function, all right? So what I like to do is use that point right there, and that's what I'm going to shift based upon these things here. All right, so remember, inside the function, in other words, what's added or subtracted to the x, okay, is the opposite shift on the x-axis. So this would mean -2. So that's right here, okay? So in other words, see this thing right here, when we put it inside, see that? Did I do it right?
Yeah.
Hold on a second, let's didn't close the thing. Excellent. I had too much caffeine or something. I'm shaking here. Picking funny stuff. All right, so it's plus 2, so that's 2. There we go. So 2 over, because it's the opposite sign. That's essentially what that is. It's like the factor, you know. X plus 2 equals 0 means x is equal to -2. That's all that means. That's why it does that. Okay. The shift on the y, in other words, it just goes with the sign because it's added after the fact. All right. And if it was plus, then it goes up. All right. So let's go back over here and graph this. All right. So where did we say this thing was at? It was over 2 and down 1. That's a vertex. And I didn't, let's see. Problem with it being like this is seeing what the XX, the y intercept is gonna be. So 4, 30, so that's right. So what I was doing is I'm just going to do it in my head. That if you square out that binomial, that means that on the end, the constant's going to be 2 squared 4, and then you get the -1. So 3 would be your y-intercept. All right. So remember, with any function, except for the logarithms, the functions are going to be negative infinity to infinity for the domain. Okay, see that? Because eventually, if you kind of imagine bending those arms down, they're going to eventually cover up the whole x-axis. The y-axis is a different story. You got to blank out the x. So go all the way down to -1 is where that vertex is at, the lowest point. And so that's going to be the lowest point, -1. So let's put those in first. And then the range is going to be -1 to infinity. All right. Now, what is the axis of symmetry? And a good way to look at it is, well, you can look at it visually, but the axis of symmetry is the opposite side of that that's next to the x there. So x minus a -2. So -2 is the axis of symmetry. Any questions about that?
No.
Okay. We only got 14 problems, so we should be able to finish. All right, here's that leading coefficient test. Helps to have a board here. All right, so the P in this case is what? Anybody remember? Good.
If
Q is the number in front. All right, so what we end up with is the 5/3, and we got to put all the factors. Okay, so this is pretty easy because both of those are prime numbers, so there's only 4 of them. Remember, you always got to throw in the negative ones. So plus or minus 1, plus or minus 5, and down here, plus or minus 1, and plus or minus 3, right? Let me know if I do something silly, because that should be pretty straightforward.
That's correct.
Now we're gonna just take all of those fractions and put them together one at a time. In other words, we got 1/1. So here's our possible zeros. Okay, so plus or minus 1, because plus or minus 1 over plus or minus 1 is just plus or minus 1. Let's do the next one. Plus or minus 5 over plus or minus 1 is just plus or minus 5. Okay, because that's all it's doing, it's just the whole number when you put something over 1. Now, let's go back and do 1/3, which is 1/3, right? One over 3 plus or minus. So we got this one, that one, and then plus or minus 5/3. Which we got a fraction here, but it's not that bad. So there's our possible zeros or roots or whatever. In other words, x is going to be equal to one of these things at least. So I would just start with the easy ones. How do you, oh, wait a minute. It's the leading coefficient test. I'm not paying attention. So the leading coefficient test says what? I was doing zeros. Oh, they got fractions in me. I know I got the thing here, but I'm gonna get out. It's leading coefficient test. So what does that mean? All right, the leading coefficient test tells us what this thing is going to do. All right, so if it's an odd, so this right here is an odd function. In other words, that's like x cubed. All right, x to the 5th, x to the 7th. They all kind of got that basic shape. So let's go back because I was paying attention. All right, so leading coefficient test. Where's the bar thing now? I don't want to even hit everything. So this is the 5th power. So it's positive, so that means it essentially does what was in that little thing right there. It rises left, means it rises, what do you call it? Falls left, rises right. So that means it looks just like this. All right. If it were negative, it would be flipped around, but it's a positive x to the 5th, so it's going to be doing this. So it falls to the left and rises to the right. And that 5th is what tells me that it does that, because the 5th, the odd ones, those are the ones like this in this picture. They almost all, look sort of like that. There's going to be some change based upon the higher the power is, but it'll still fall to the left, rise to the right. Does that make sense? And we could even look at it. We just were to put in x to the 5th, you can see it. See that? It looks very much like x to the 3rd. It's a little bit different. Now, let's just say if we had the negative, what happens? Then it rises to the left and falls to the right. that negative sign. So that's what the leading coefficient test is. I won't go back, I can do something I didn't need to do. So we all right on that? And if it was positive, so this is going to look. If it was, I'm sorry, I'm not positive. If it was even, say, they most all look the same. It's falls to the left, rises to the right. So actually, it rises to the left, rises to the right.
I was about to say it rises on both.
Yeah, it rises on both sides. Sorry about that. And then if we were to take and negate it, then it flips it. Okay. And then so it falls left, falls right, right? Okay. All right, I just want to make sure I went over everything like this, kind of bone that. So I'm going to take the time here, so we're going to get 14 problems. All right, so the multiplicity for each zero, okay? So what are the zeros? Well, if x is -8, then we got a zero, right? If x is -6, we got that. But the multiplicity for the second one is 2, right? So the
Yeah.
zeros are -8, -6. So let's see, there are 2 zeros. Well, no, there are how many?
1.
Here's one of them. And here's 2 of them, but, okay, let me see if I'm gonna get this straight here. You remember the fundamental theorem of algebra, if you have, like in other words, if you have x cubed so you got 3 maximum, 2 of them can be the same, but there's 3 spots here, 1, and then this is considered 2 that repeat, all right? Even though the 3, the leading coefficient right there tells you the maximum amount of zeros that you have. Okay, you remember that? That's what's called the fundamental theorem. It doesn't mean that 2 can't repeat. So in this case, going back to this one, then how many?
It'd be positive and -6.
Oh, you're right. Oh, yeah, negative.
No, I'm saying on the 3, if it was C.
Yeah, because the thing is, okay, technically it's this, but 2 of them are the same, so there's only 2 of them. Okay. And so just because we have a square there, that means that 2 of them are the same. And like I said, if we graph this, you can see it, but we've got plenty of time here. So here's one of them. There's -8. That's the smallest one. And then this is the largest one. Like I said, it's technically 1, but you got 2 the same time, and 2 twice. In other words, they count that as twice because it just kind of kisses it. It doesn't technically go through it twice, but it's only 1. So the graph crosses the y-axis. Because of this thing here, right here, this is the one that causes it to cross. All right, that's a single power. In other words, that's x plus 8 to the first power. So it crosses, it actually has to actually cross at that point. And then it touches at, well, no, it doesn't touch, it doesn't have that option. I was going to say it touches at -6. So this is what it is, and it turns around at -6.
They have and touch the x-axis and turn around and -6.
Yeah. So it touches, or it's like kisses it at x equal -6. That one was twice. That's why the multiplicity thing comes in here. The multiplicity twice, that means it's a turnaround point. If it's a single power of whatever that factor was, x plus 8, then that means it actually crosses that. So let's just say, that's kind of showing it right there. There's the crossing point. That's the one that only appears one time. That's a power to the 1. See? So we don't really need it, but that's even. If we were to put a 3 there, see, then it crosses at that point. Still, if we would put a 5, it still crosses at that point. If we put a 7, it crosses at that point. If you were to put another square, it just kisses at that point. It just touches. Okay? So that's what they mean by multiplicity. The multiplicity of the factor tells you whether it crosses or it touches only. And if it's an odd one, it crosses. If it's an even one, it just touches at that point. Okay? So we put it back the way it was, but I just want to make sure that we understand about the idea of multiplicity. It's the power of that particular factor. Now, in reality, though, they're factored in for you so you can see them in this section. All right, so here's the leading coefficient test again. All right, it's positive. So this is like another parabola, all right? The parabola. Can you all see my? That's not true. But anyway. So we got an even power. So that's another. Anyway, I'll show you a little bit. So see that? Leading coefficient test. So that's rises left, rises right. And it's positive. So rises to the left, rises to the right. And the x-intercepts are you know, factor this in. Yeah, we can factor out x squared. Take that off, but we're not going to need it. So this factors as okay. So they fixed it to where we can just factor out that x squared, and we set each one equal to 0. So x squared is equal to 0, which is just going to be x is equal to 0. No matter how many x's you have that are equal to 0, then x is going to be equal to 0. So this one right here is that perfect square. That's x minus 2 squared is equal to 0. So that's x minus 2 is equal to 0. All right. So the x-intercepts are 0 and 2. That makes sense?
Yeah.
Okay, now, so let's see, what else do we want? Okay, it crosses, so we gotta look at the factor. They're both multiplicity too. So these are both, which x-axis x across the x-axis? Or x-intercepts. It's just that it's touching at that point.
I
So
thought it would be there, although
yeah,
I thought it would be B.
yeah, it is. I just was
Oh, okay.
confusing the first one and B and that part, but yeah, they're getting technical about, because they said x-intercepts 0 and 2, and I thought they were asking something different there, but yeah, in other words, it doesn't cross at that point, it just touches. Well, now they're asking the same thing. I don't know why they hit that part. Doesn't seem like it's just doing that. So the y-intercept is 0. And how can we tell that? Because if you put in 0 for x, what's the value of the function going to be? It's going to be 0 because there's nothing hanging off the end. Because 0 is x is a factor of everything. So that I guess we didn't put 0 comma 0. All right. So this is going to have, it's a parabola type thing. So it's not negative. So it means it's going to be one of these two in the middle. All right. So it was 0 and it was 2, wasn't it?
Is B.
So it's got to be that one. Only choice. It's got to be this one. Because there's 0. And then 1, 2 in that one. So it's B. This would be negative 2, 0. But we know it's not this one or the last one because the x to the 4th is positive. So
It'll be a reflection.
yeah, it's not. But if it were negative there, probably you'd have to negate all the rest of them too. You have to negate the whole function. It would flip it down. So it's symmetric about what? It's symmetric around x equal to 1, right? It's not symmetric around the origin. It's not symmetric around the y-axis. So it's neither one. It is symmetric, but it's the point of symmetry is x is equal to x is equal to 1. But they don't give us that choice. Lance? What's that? Where am? Mm-hmm. So sure what you're saying, okay? Am I missing something? This is x minus 2 times x minus 2. Okay, which is x minus 2 squared. So but it's squared, it's just going to be that turnaround point. So x minus 2 is equal to 0. X minus 2 is equal to 0 means x is equal to 2. Right. Because I'm factoring this. This factors as x minus 2 of x minus 2. So let's look. I mean, this is a perfect square, so I'm just kind of going from that. But anyway, look, the factors of 2 that add up to be 4, well, 2 and 2 And they both gotta have this sign, because this is positive. So -2 and 2 are the factors. So that's how I got x minus 2 times x minus 2. See that? It's a perfect square trinomial. And like I said, you can still factor it by the way that I teach the 097 students about, look at that third number, the number hanging off the end. The 4 is positive. So that means we're looking at the factors of 4 that add up to be that middle term. And that middle term tells us what they both have to be. So 2 times 2 is 4. And 2 plus 2 is 4. And then that -4 means they both have to be negative factors. Okay? Well, like I said, the way I did it is after I factored the x squared out, I can tell that it has that what we call the form of a perfect square trinomial. And this is something that we go over. And I mean, I didn't know you were doing Roman stuff, so I mean, I'm 100% sure if we had this, but let's just kind of look at this, just in case anybody else has got a question about it. So what we call a perfect square trinomial can have one of two shapes. All right, it can be like this. Okay, a plus b squared is equal to, and the way I look at it is, okay, the first time we're going to get squared. The second term is going to get squared over here, and it's going to be positive. And I don't feel bad that I'm going through this because I have students, even though with an 096, they still, 097, they, still have questions about this. So that's why I'm not worried, about it. And now what I want to do is I multiply a times b, which is just ab. Now I use that sign there. And then I multiply this a times b by 2. It also applies to a minus b. Right? The only thing that's going to change here is the sign here. Okay? So let's go back over. Now that you see that pattern, look at this thing over here. See that? This is x squared. This is 2 squared. And then this is exactly, so x squared, 2 squared, 2 times x is 2x times 4. I'm sorry, 2x times 2 is 4. And then that sign comes up. So you see that pattern? That's what we call a perfect square trinomial. And this is the one when the factors are both, when the factors are both negative. They always have that pattern. So you can save yourself some time. And like I said, the way that I show people in 097 about just regular factor, and I said, you may not be able to catch on to that. Like I said, I never did. It took me a while to catch on it. And the way that I caught on to it, which is factoring these things a bunch of time and then start to see the pattern. But as I said is, the factors here are -2 times -2 to give you +4. -2 plus -2 give you the -4. So you can do it that way as well. But I was taking advantage of the fact that it was a perfect square trinomial, as we call it. Okay, so that's how I got that. But that's a good question. And I bet you other people have a question in that. All right. Okay, here we go. See, I was expecting this. I don't know why. I was expecting this to be first. And I know the reason why now is because in my 128 class, they're only testing on this right here. It's their third test too. And they're only testing on this topic right here and the thing where we found the inequalities. So that's why I was a little bit thrown off at first, because I was expecting this to be first. But y'all got a little bit more in your test. All right. So all right, so here we're doing what I wanted to do. So P, Q over P, right? So Q is equal to P
6.
is equal to -3. All right, so we need the factors then. They're going to be for Q, it's going to be plus or minus 1, plus or minus 2, plus or minus 3, 3, and down here, it's just -3, so it's, but when I get the negative, doesn't matter, it's still going to be plus or minus. And this is only has 2, because 3 is a prime number. All right, so let's just go through with them for all of them. I'll put right down here. Possible roots. So obviously, plus or minus 1 is one of them, because we're going to put this one over that one. And then I'll do this one, that one. So that one's plus or minus 1/3, right? Thankfully, it's not going to make us work them all out. But so we got this one and that one. So now I start with 2 plus or minus 2, because that's 2 over 1, plus or minus 2/3. Then I'm going to go on to the 3. So that's plus or minus 3 over 1. And then 3 over 3 is just 1, right? So that one's already listed. So let's go on to 6, plus or minus 6. And then plus or minus 6 over 3, which is plus or minus 2, right? We've already got that one listed. So they've got them all. Let's go ahead and list them like that. So that way we pick the right one. It's not going to be that one because I don't see 6, so it's going to be one of these. But so I'm going to try to write them in the same order. And then -3, 3. And then they do the whole numbers first, okay? And then they go to the fractions. And then we got 1/3 and 2/3. All right, so it's this one, isn't it? Make sure. Because we don't have 1/6. There wasn't
Yeah, it's,
at the bottom, so it's this one. Correct?
yeah.
Okay. All right. Now, thankfully, they're not going to make us go through and check all those, because the ones with the fraction are a pain in the neck. And I think for the most part, they don't have any of these, because I went through and looked these before, like I said in my earlier class. So consistent. All right, so they want us to list it, and thankfully, see, they only got a 1 there. All right. So Q is 18. P is equal to 1. So then that's just going to be down at the bottom, it's just plus or minus one. But up here, we gotta list all of them. So that's plus or minus one.
Wait, you say P is what?
It's one, and then another.
Oh, okay.
And here's the equal sign. Isn't it one? Isn't it one to them?
Yeah.
Yeah, I just have to slow down. Like I said, I didn't really have that much caffeine, but I got here early, and I got here early before the building opened, and the policeman yelled at me for getting here so early. So I went and got coffee, and I don't usually drink coffee in the morning. I also have a Coke, so. Yeah. All right. So, anyway, let's see. 18 is going to be plus or minus 2. And that's going to go with 9. We can have 9 in there. Then I'm just putting them in order. All right, so 3 and the 18 goes plus or minus 6, right? This next one. And then plus or minus 9. And then plus or minus 18, right? And they're all over 1, so it's just the ones on the top. So what we're going to put in, -1, 1, -2, 2, -3, 3, -6, 6, -9, 9, -18, 18. All right. Close this. So I can see them all. I didn't get them all right. Basically, you just got to get all those factors. And like I said, usually these ones are where they actually have you do the zeros and go through the whole process. They're not going to give you too many of them. So how many is that? That's 4, 6, 8, 10, 12. So that's not too bad. All right, so we got to test each one of those. All right. So I'm just going to start over here and see what happens. It was an x cubed, wasn't it? So really, all I have to do is find 1, and then I'll have a quadratic, and I can use the quadratic formula. I'm starting with the -1 because that's
It was
first.
2.
What's that?
Say it should have been 2 as the
Did I miss something?
No, I'm following what you're doing.
Okay, I'm just going to go through it one try. I had 19, it was 18. All right, so we're just going to go through. I'm going to write the darn thing down. Let's see. 1, -2, -9, 18. Got to get the signs right. And if there's anything missing, what do you got to do if there's one missing? In other words, if there's a term,
0.
like if there was no x, not if that 9x wasn't there, negative, you put a 0, okay? If one was missing, because you can't skip one. If one's not there, then it means that it's 0. You got to put it in 0 as a placeholder. Bring that down, -1. 1 is -1, so that's -3. -1 times 3 is 9. Oops, 3. And then that's -6. I was anticipating this was going to be 0, but it's not. So that's 6. So this is going to be Doesn't even matter what it is. It's not zero. You remember what this does tell you though, is that tells you the functional value of the original function at -1. Well, that's a good thing to know because in some ways this is easier than sticking it in for x, you know, and doing that math. But so in other words, f of -1 is 24. But it doesn't, I don't think they're asking about that. They may ask something like that at the end, but we'll probably see one of those. I'll just remind it. Oh, we're like. I'm gonna have to move. Okay, so now this. So maybe the two, I'm just gonna go in order because I could skip around. But I really found, for the most part, that I have success by just starting in order and going and find one without too much trouble. It's not this one. So if you see anything that I've done dumb, I'm doing quick because like I said, I started since got 29 minutes. I slowed down particularly because I said, oh, we only got 14 problems. We're barely halfway. All right. Here we go. So x equal to 2 is one of the zeros. So this is what, so pay attention to this. All right, that means that the factor is x minus 2. Okay. In other words, the reason why that is because 2 makes this thing 0, 2 minus 2. So then we take the coefficients. That's x squared. We don't have a middle term. We've only got that 9. We don't even need the quadratic function, which is what I've noticed on most of these that I've seen. You can factor that because what does that one right there factor as? That one is called the difference of squares. That's x minus 3 times x plus 3. All right. So what are the solutions? It's 2, 3, and -3. So we got that? I'm not even going to put them in. Well, we got more stuff to do. So the one rational one was 2. And then this one was 2, 3. All right, this is pretty much just like the other one, but is anybody interested in seeing it? If I'd have known that this one was going to be here, I would have skipped that other one because that other one might have been a bit shorter. This one is just they're both cubics, but so it's the same thing. Basically, you're going to go through all of these. They've got them for you. So let's just move on. All right, so remember what this right here means. 4 from the negative side. So x equal 4 is right here. 1, 2, 3, 4. So from the negative side, that's not -4. It's 4 from the negative side approaches what?
5,
It's going out towards,
infinity.
Infinity.
okay. See, down here, if it were going from the positive side, it would be negative infinity because it's going down, all right? Same one, okay, let's do this. Now this one is saying as x approaches infinity from a negative infinity. So as it does that, what's happening to the y value? Let's pull it through.
It's
So
going
as
up
we
to
go
infinity.
to the negative infinity, it's approaching x is equal to, I'm sorry, y is equal to 0. So that's a good one to know because, so this is from the positive side. So that just means look at 2, and we're approaching from this side. So what's happening to this?
It's going to positive infinity.
Yeah, positive infinity. This is good because these are kind of like easy to me, but if you want me to slow down, I'll just ask because like there were several levels. And usually if you can get one, you can get the rest if you just understand the path. So this is x is equal to -4. So -4 right here, but we're coming from the positive side of it. In calculus, this is what they call a limit, essentially. In other words, what happens to the value as you're approaching from the positive side? So it's -4, so we're coming over here. So this thing is going to downstairs, negative infinity. Because right here, we're talking about what's happening to the y. So as we're coming across from the right, which is what the positive means, and going towards -4, that thing is going down. And just incidentally, you don't have to know that. But see, this one was positive infinity, this one's negative infinity. All right? Yeah, that's the thing that they talk about with limits. All right, vertical asymptotes. We essentially solved that. The denominator. So x times x minus 6 is equal to 0. So we solve in the denominator. In other words, what's going to make this thing undefined? That's the way you would have had it up to this point. So yeah, this is a crazy, just a plain equal sign. So x equal to 0, x minus 6 is equal to 0. So x is equal to 6, and x is equal to 0. So the vertical asymptotes are 0 and 6. That makes the denominator 0, and that makes it undefined. Questions? Remember, that's the difference between the horizontal asymptotes. The horizontal asymptotes, I almost have to keep looking back at the rule, but you basically divide the highest power in the denominator and the numerator. This is the vertical asymptote. That's where it's undefined because of the fact it's x. So solve the polynomial. So let's go over here. Now notice it's greater than 0. I remember, and I can't remember if it was this class or not, but I was doing one of these. And I did it and I had it, and I was wondering why it wasn't right, and then I noticed it's less than, it's the opposite. So it says greater than 0, so we're looking for values of that. So let's just factor it. All right. So this factors as, well, we'll first just write it out. In other words, they say treat it like an equation.
Should be and -3.
Yeah, right. I just wanted to write it out. Okay. So it factors as x minus 3, x minus 9, right? So x is equal to 3. X is equal to 9. All right, so that's our points. So let's say that's 3. And then this is 9 up here. So we got to pick something in each one of these spots. Something in here, here, and here. All right. So let's just pick one over here. All right, and since it's greater than 0, then this comes out positive, then that means we shade that section. Let's shift x is equal to 1. And remember, 1 is down here somewhere. It's not a critical point, but it's a point we're checking. So what happens when I put it in there in the original function? Say 1 squared minus 12 times 1. This one's pretty easy. That's why I picked 1. So 1 minus 12 plus 27. So that's 28 minus 12, which is it's going to be positive. So it's 16, right? So that's positive. Since we want greater than 0, then this section's got to be shaded. All right, and it's less than, so we I'd almost guarantee that 1 in here is not going to work, but let's try it. Let's just try 5. All right, so 5 squared. Let's see if I can make this bigger. X is equal to 5. So 5 squared minus 12 times 5 plus 7. This one may be positive also. Let's say 25. And 12 times 5, is that negative 70? 60. Negative 60, thank you. Oh, and so it's going to be negative, right? Because 25 and 27 would be 52 minus 60 is equal to negative 8. So this is negative. So not in here. But if we put in 10 over here, I bet you that one is 5, not 9. All right, so this is 10. Because we're always checking something that's in between. So 10 squared minus 12 times 10 plus 27. So this is 100 minus 120 plus 27. So that's going to be positive. And I'll finish working. So that's 127 minus 120 is equal to 7. So that's positive. So there we go. So the solution set is infinity. Let me write it out here. It's negative infinity to 3 union with 9 to infinity. All right. So it's this one. Okay. Great. Union. So you put them together. All right, questions on that? We're doing all right on time, so don't feel pressure or anything to not ask anything. We got one more, and then I can even go back to the one that I skipped if you want. That was another
Yes,
one.
you can do that.
All right, so this one, remember, and just, I don't think 100% sure that you have one, but just remember, when you got the rational ones, you gotta have one fraction on that side and then 0 on the other. This one's already got a single fraction, but if it didn't have it, you'd have to combine it, you know, find the least common denominator and all that. All right. So there's still a greater than, so we don't have to worry about the equal to business. And remember, this is going to be one of the critical points down there, and that it can't be that either. So these are going to be all parentheses. All right. So define the critical points by doing x minus 6. That comes x minus 6 is equal to 0, which means x is equal to 6 is one of the boundaries, and then x minus 1. Okay. All right, so that means it's kind of funny looking at for A is nothing. All right, so again, 1, 6. So these are the ones that create our boundaries. So in here, it doesn't really matter. Let's pick x equal to 2. I'll even do it up here. So 2 minus 4, 6 over 2 minus 1. All right, so it's not going to be that because it does say greater than 0, right? So that's negative, so that's not one of them. So this part is not. So we're going to do one, let's put negative 1, actually, put negative 1. So that's negative 7 over negative 2, which is 7/2, which is positive. So this was negative, so that's what we did. So right here, that's part of the solution to the positive over there. Let's see. Let's say x is equal to 7. So 7 minus 6, 7 minus 1, 2, 1, 6. So that's positive. So that's again, that's negative infinity. 1. And then 6. All right, so this is it, right? Oh, 1. Oh, that's it. All right, so y'all want to see that other one that I, wait a minute. Oh, I didn't put this. Oh, y'all want to see that last one? I
Yes,
don't know. I mean, the one that I skipped one because I started getting worried. I think it was gonna be kind of long. We probably won't be able to finish it anyway, but it was this one. But that, it's pretty much the same thing as the other one. So, you know, you're doing 7/12 thing. So, it's gonna be this one.
I was about to say,
'Cause it's not 12/7, it's 7/12. So I would bet you it's that one. But then you gotta go through and check them, which is probably gonna take a while. I would probably, it might be that the 1 and -1 or the 7, -7 does, you know, gives you 1. And then the same thing's gonna happen on this one. You're gonna get that, probably that difference of squares and factor it, or you can put it in the quadratic formula. All right, so while I'm thinking about it, let me change